Recording, sharing screen. Going to the next one. Find the proportion of observations from the standard normal distributions that are between negative 0.58 and 1.79. Okay. How do we do this? How do we do this between?
Do you have to use that table in that book?
You can.
Can you do it on the calculator too?
You can. Yeah. She said, is that under normal CDF? I said yes. Okay. So normal CDF.
And how do I get to that again, Miss Jones?
Second bars.
Okay, so second bars.
PDF. Eventually we'll do PDF, but not right now. If you're going to do it in your calculator, you need to make sure that you write down everything you put in your calculator. Okay. So what's your lower? What's your upper? What's your mean? What are these? What are these two numbers?
They're z-scores.
Z-scores. So we standardized. So what would our mean and our standard deviation be?
0 and 1.
0 and 1. Well, this one is because it gave you it said the standard normal distribution. So that should already tell you 0 and 1. And you know that these are z-scores. Okay. So anytime it's z-scores or it's standardized, it's always 0 and 1. All right. So what do we get? That's it. So the proportion is 0.682. You can leave it like this. If you want to write it as a percentage, you can do that too, but this is perfectly fine. Okay. Any questions?
Is this how it's going to look on our test?
Uh-huh.
Okay, it's not going to be any like wordier or harder.
No, not on your, no.
Okay.
These are more like your free response on your test. Your free response should be fairly easy for you this week. The multiple choice is the one that's going to be a little bit more difficult. Okay. All right, 118. All right, so this is what I was talking about. You can see right now that 115 and 6 are not standardized because obviously it'd be 0 and 1. So you know those kind of numbers are not. Usually if there's a little decimals, you know that those are going to be standardized. So it says about what percent of Nadal serves would you expect to exceed 120 miles per hour? Exceed is greater than. Is everybody good with that? So then we're doing it the same way. We can do it in our calculator, normal CDF. What is our lower going to be versus what is our upper going to be? What's our lower? 120. Perfect. 120 because he wants greater than that. So that's the least we can get. What's your upper?
Is it just a big number?
Yep. Big number. I always use 10,000.
Ms. Jones, I have a question.
Question away.
If the upper number is like what we're looking for and there's nothing to put in the lower, do we just put 0?
No. You want to put like a negative 10,000.
Okay. I just couldn't remember what we put for that.
So if it said less than, remember in your calculator, you don't have to worry about less than or greater than. It's when you're doing it in the table. So if it says less than, the only thing that's going to change is this would be negative 10,000 and this would be 120. That's the only difference.
Okay, thank you.
You're welcome. What's your mean?
0.
Nope. Look at it.
115.
Yeah, be careful on these. Right there, and a standard deviation of 6. What's it give you? So about 20% of his serves would exceed 120 miles per hour. Is everybody okay? Not too bad, right? Again, these are more like your free response. There's a few, the Z-scores and stuff like that in your multiple choice. What about between 100 and 110? Same thing, normal CDF. What's the lowest you want it to be? 100. The upper. Your mean and standard deviation are still going to be the same. The mean was 115. And the standard deviation was 6. What does this give us?
0.196.
And I got 1961, which is the same. So about 19.6% are between 19.61% of the serves are between 100 and 110. Okay, so if it asks you to interpret, that's how you interpret. Everybody good? All right. 120. The heights of 3-year-old females are approximately normally distributed with a mean of 94.5 and a standard deviation of 4. What is the third quartile of this distribution? The third quartile. How do I do that?
You put it into the calc and then you put area under 0.75.
Where do you put it?
Second vars and then end norm
Okay, what does that give you?
gives you the number that has 0.75 of the area under it, which would be the third quartile.
Is everybody good with that? All right, so inverse norm. Remember, if you're using your calculator, write it all down. Y'all, I'm telling you, they'll count it wrong in the AP exam if you don't put all this stuff on there. Area is 0.75. What's your mean? And your standard deviation? 4. And then what do we get? Good. So the third quartile is 97.19. One more. This is on your test at some point, so make sure that you know what you're doing. Use the histogram and normal probability plot below to determine if the distribution of areas for the 50 states is approximately normal. So you tell me. What are they? How do you know they're skewed right? Good. Again, we don't use these much, and we just talked to, this is how they'll do them. They'll typically compare them. They don't test on these, but they help you understand if a linear model is good or not. So we'll be talking about that later on. But again, they don't really test on those. But you can see from your histogram that all your data is on this left side. So that means the tail is on the right. So it's skewed right. What else do you see? So there's an outlier on the high end. That keeps the distribution from being normal. And that's it. All right. Stop share, stop